Right. Good morning, everyone. We are from Tata Communications, and we'll be sharing with you our project on secured lifecycle management, image management. And I'm Pratik. This is my colleague Abhijita, and Mayank unfortunately could not make up for the presentation. So for the next 40 minutes, we'll be taking you through our business landscape, the kind of services that we provide, the kind of management of the infrastructure that we guys do, and what challenges does it bring when we do these things. And to overcome those challenges, we'll look at the goals that we have set aside for this specific project. And while arriving at a solution, what kind of technological studies that we did, what kind of gaps we found, and the kind of design goals that we have set for this framework to really work in our environment, at least for this project, and the architecture, what we have designed it to make it seamlessly work for our requirements. Some of the future enhancements that we are really looking forward to it, and Abhi will be taking you through the demos part of it. All right, so this is a hybrid ecosystem that we are talking about, that we have in our cloud infrastructure. So we provide services across virtual machines and containers to our customers. We provide a private cloud service to them. And we create these virtual machines on top of different hypervisors, which is VMware ESX, KVM, and Hyper-V. And then on top of it, we do have containers as well running as a service. And this whole setup is being deployed at multiple data centers across the geographies. And then orchestration of this whole infrastructure is quite, it's quite matured, because OpenStack has matured, and the drivers and the infrastructure level details have been embedded enough in OpenStack that we can seamlessly create any VMs, networks, senders, and everything, unless there's an infrastructure glitch. The other thing that happens with this infrastructure is you are able to create VMs, you're able to create containers, networks, everything, but how about their images? Right? So the concept is not that you can use the same image for everybody. I cannot just have a plain CentOS or a RHEL image or an Ubuntu image and let anybody come in and then start running everything on top of it, right? So when we provide our services, we are targeting typically our enterprises. And in this case, what happens, these enterprises have set aside, or they have designed their infrastructure already. They have their applications running at some on-prem or in some other cloud, and if they want to come and work on our cloud, they have their own requirements. So in a case wherein enterprise can say, I have a 3-tier application where is a web messaging queue server, and then you have a DB. Now they come and say, for a web, I want /var to be 20 GB probably. For messaging queue, I want /var to be 50 GB, and for database, I want it to be 100 GB. And few more other operating system specific tuning for maybe RabbitMQ or the messaging queue and the database, right? So they come with the specific customizations for each of their components. And if we try to honor these, what happens is we kind of spend time on to create those images for them specifically for those components or their deployments. Now when we do that, we realize, as the number of components in an application will grow for a customer, or as the number of customers will also grow for you, right? What will happen is there will be lots and lots of images that you'll end up managing it. Because there could be 2 customers who are asking probably the same kind of customization within an image. How are we going to do it? So that's where our challenges within our service is, wherein we want to have a quick provisioning time of customized images, not just a bare image that is out there, the cloud-ready images. When we talk about customization, and since we are hosting enterprises and a private cloud kind of infrastructure, we want to ensure that our platform is safe and secure for everybody to come and play around over there, right? Nobody would want to pay a price of someone else's mistake. So a customer A comes in and he does some customization on his image, which probably opens a vulnerability for somebody. Now if there is a backdoor to it, my computes are gone, the whole infrastructure can go for a toss. So we don't want anything like that to happen. So with customization, security is a prime challenge for us. Now when we talk about customization again, right, so the elasticity feature of a cloud, wherein people want to auto scale within an environment whenever the CPU load increases, or they want to go to a cloud burst to go to a different cloud, they want to do it, right? All that needs images to be ready so that the load sharing can happen immediately with the minimal latency that can be required by the applications. So when we customize, we looked at the customization has to be done in a way that it supports elasticity with the level that the customers expect from us. The goals that we set aside to overcome these challenges is, first thing is build customized images across your ecosystem, because we are talking about cloud bus, so it's just not OpenStack. You should be able to create images across your AWS, Azure, or whatnot. Then you talk about platforms, because today in the hybrid world that we're talking about, not necessarily that some customer comes and he says, I want only VMs for my ecosystem. I may want to host my web on our containers, my database on virtual machines, and use some analytics on bare metal. So he would probably want an ecosystem. He wouldn't want something very specific to our VMs, right? So we should be able to create images across that. And virtualization techniques, because we are a hybrid guys, so we have to support for image creation for ESX, KVM, and Hyper-V all. Other things that happens is, like we just talked about the elasticity, we have to ensure that the images are complete in itself. That is, you just take an image, spin a VM out of it, no add-on customizations, and your VM is up and running, and it's able to share the load immediately. So that elasticity has to be met, and security is the other thing that we have to ensure that it goes through a certain scanning process. So what we looked at is there are different image creation tools that are available in market. There are scanning tools that are available. Some of the image creation tools to mention are Packer, Word Builder tool. There is a Disk Image Builder. There is a VMware Image Builder as well. Now these do their own task in their own fashion, right? And similarly, you have scanning tools for OpenSCAP, OpenVAS, Black Duck, Twistlog for containers and everything. But we couldn't find a platform which could connect both of these pieces, do the kind of customization that we guys have been seeing, and scan the image to give you a safe and secure image which can run on our platform. That's where we thought of, we planned out how to build this solution. So we defined 3 pillars for this whole framework. We have the first pillar is the build, where we want to really create that customized image, which is complete in itself again. And the second one is the scan part, where we want to examine once the image is customized and created, it's available somewhere, go and scan it, examine it from the industry standards perspective, the kind of vulnerabilities or issues that people have already said or already mentioned or already have seen, go and try to find those signatures within the image and declare whether the image is safe and secure to be, to start up and running in your ecosystem. Given that you have a safe and secure image, now what do you want to do with that? Now there are 2 ways. One is you can have somebody go to your OpenStack deployment or your containers infrastructure or somewhere, go and pull that image from wherever it is hosted on a central registry kind of concept. But then what happens is you would have created an image for somebody, and somebody is going to try to upload it to your OpenStack environment. There could be a disconnect, and you might onboarding a wrong image. So you want to integrate that piece as well with this solution, wherein when you're creating an image, you specify where do you want to host it, in what context, maybe a tenant or maybe a project in case of containers or Kubernetes, anything. So we want to cover up the whole thing end to end. Now with that solution in mind, what we look at is building has multiple actions to be performed before we can declare the image has been customized, right? So if like I mentioned earlier that there could be 2 or 3 customers who want to look at similar kind of customization across the same image. In that case, what's the best activity to do? Do you want to create that image again from the scratch, or do you want to reuse that image? So what we thought is best is to reuse the image, because our goal is to quick provisioning of a customized image, right? So we want to have a searching mechanism within our framework, which can go and look at the image from a customization point of view, not just the image, name, or version, or anything from that point of view. So customization should also be searchable. And if it is not found, then go ahead, customize the image, build the image, and once your image is built, what you would want to do. So you may be building it for OpenStack kind of platform, but if you're talking about cloud burst kind of feature, you may want to save it as a template so that you can build for AWS or Azure kind of platforms as well. Right? Now we have been talking about customization of an image. What we want to just bring out here is what all we have seen as people coming and asking for customization within an image. So there are a lot of things that people generally ask. They want number of interfaces to be customized. They want one as outside facing interface. They want one an inside interface so that they don't, collide with it, and then you have different kernel and OS level tuning wherein they say large packet transfer, I don't want swapping, I want some other parameters specifically for their application or their ecosystem to be set. File system has been very common wherein you want var, opt to be of different sizes, or you want to create your own logical volume and file system on top of it. And since these are enterprise guys, they will always have their own softwares. Not everything might be Apache or Tomcat based. They will even have their JIT source code. They might have their proprietary binaries that they want to bring in. So all those things have to be embedded into an image. And hardening levels are something, those are security policies that every enterprise has within their own environment. Some of them, they say that passwords expiry is 45 days. Somebody says password expiry is of 30 days. So there can be a lot of other levels that these guys would come up with. Startup scripts, again, they want, their application needs something to be set before they want to start their application every time the VM reboots or anything that they want to do with their application. So they want to customize that as well. And varied configuration is typically the user level configuration that they want to do some sort of environment variables or any of the other user library settings. So what we've done is we try to customize, create the categories for these customizations. The first being the system devices, where we want to customize something at the system level, where is the networks, the file systems, and things like that. And the second level we are talking about is kernel parameters. And in kernel parameters, there can be some parameters which can be tuned on the fly, which doesn't need a reboot. Others would need a reboot. And then the software customization, which is typically your user level customization, which can be just done seamlessly. So as in today, what we do is there is a manual and semi-automated method which is combinedly used. At system level, you would probably go and spin off a VM, customize it, and they take a snapshot. Similarly for kernel parameters tuning, which needs reboot. Others can be done as a via cloud init, or you could even have a custom script embedded into the VM, and whenever a VM spins up, that custom script executes. But what we are looking at is, let's not do all this. Let's have a clean way of fully automated way, wherein you just specify the customization that you need, be it system level, be it at any user level, and the framework takes care of building a pre-baked image which is complete in itself and be able to spin and take the load as it goes on. So considering these factors, we set ourselves the design goals, and the kind of decision that we have taken for this design is, first is build. We want to build anything, right? Across the ecosystem, the platforms, the virtualization things that we have talked about. So while we were studying about the tools, Packer stood out as a biggest contender for us because it has the capability to build across AWS, Azure, and a lot of other things that it supports, and it's also a plugin-based method. And then we wanted to have secured images, so we went for OpenSCAP as a image scanning tool because it could do scan of bare metals, virtual machines, and containers. And it has chroot kind of capability where it can scan anything that you want. And then we want to publish it. So what happens today is, all your Kubernetes, OpenStack, any other endpoints that you, or any of the cloud ecosystem that you talk about, they all are API based. So what we thought is, let's have an image, host it on local or on a central registry, and then call the API of the endpoint where you want to take an image. Set the API's parameters in a way that it goes into its right context. So that way, so no interference, no chances of a manual error around that area. These being the parameters to consider here, but from an infrastructure point of view, or the framework point of view, we looked at scalability because we want to create multiple images. The customers could be asking for, 2, 3 customers could be asking, or there could be any number, right? So we used messaging bus and multiple image builders that can run parallelly. Flexibility, there has to be a plugin-based model. We don't want to restrict you towards Packer or say for some image building for Linux Kit, if you guys want to use or anything, come and plug and play and use it. And then we talked about reusability because we want to templatize it. And once we templatize it, whatever customizations that you have, I can use the same thing to build any of the image or on top of it if I want to build anything, right? So with that being said, this is the architecture that I want to walk you through with. What we have is we have developed a dashboard wherein customers can come and start entering or searching whatever customization they want to do. That request will go to the scheduler, and that scheduler will go and push the data into the database. Now, apart from storing who's building, what kind of base image you have, we also save customization data within that database as well. And once he enters that, the message is sent to the messaging server, saying that this is an image, waiting for image building. And then we have defined out as an image core here, which consists of 3 things. One is image building. Second is image scanning. The third one is, if the scan says image is safe and secure to be used on the platform, go push it to our central registry, where it can be again pulled by the other endpoints. So all of these communicate via messaging server, and they pick up the image details from the database. So once the image has passed the build phase, scan phase, the push to local registry component pushes it to the central registry. And once that's done, now it's time to go and publish it to the endpoint that we have been talking about. So push to local registry will go and signal the publisher, saying that go and take an image from the central registry and go and publish to wherever you want. So endpoints could be your OpenStack or anything, and then the image could be for the bare metal containers or VMs. All right. So some of the future enhancements that we are looking at doing here is, although we are able to customize, create an image and publish it, but we want to have a reusable customized image, wherein today a customer comes and he says, I have var/var file system should be about 20 GB. Tomorrow some other customer comes says, I want var as 20 GB, but I want opt also as 20 GB. Why don't we go and reuse that whole template, that image, and customize on top of it? There's no point in starting again from scratch. And searching, so we have saved the data today in the database. All we have to do is we have to start making it searchable based on the customization parameters that I've used. We should be able to spin VMs is what we are looking at. Let's not get the VM onto the endpoints or the cloud infrastructure that you're talking about. We should be able to spin VMs or create heat stacks out of it, or any of the infrastructure deployment that you guys want to do it. And saving templates, that's not yet done, but that's what we are looking at. Save the templates and reuse them to create any other image in future that you want. And then why not have CI/CD for everything? So assume that you have built an image on a template. Now your jet source changes or something. If you set a trigger point over there, your base image will be rebuilt again. It'll be scanned again, and it'll be pushed to local registry and published. And what if that publish also can respin your infrastructure because your new image is present? So that'll be a lot of seamless activity across VM, VMs, and containers kind of infrastructure. So that's what we are looking at. And now I'll have Abhi to share the demo with you guys.
Thank you. Well, good morning, everyone. So here, our framework primarily consists of 3 phases: building, scanning, and publishing. In building, as we talked earlier, we use Packer as an image building tool, primarily because of its provisioning capabilities, where you can use customized scripts and customize the image the way you want. And for scanning, we use OpenSCAP, which is widely used for vulnerability assessment. And how do we do that? So OpenSCAP uses security policy documents, which is publicly available in the form of OVAL files. OVAL is open vulnerability assessment language. So there are vulnerabilities which you describe as a definition in an OVAL file and scan the image against it. So OVALs, these definitions are also called as CVEs, commonly known in public as CVEs, and which is common vulnerability and exposures, which are available in public database, that is National Vulnerability Database maintained by US government. And for publishing, we issue a glance API request to onboard the image to registered corresponding OpenStack environment. So to demonstrate the capabilities of our framework, we derived 3 use cases. The first one is building an image where there is no vulnerability, and second one, building an image with vulnerability and prevent it from publishing to the registry to make sure that registry is clean and safe. And third one, build a Docker container with Ansible provisioning. Yeah. So here in the first demo, we use CentOS as a base image and select the predefined provisioners. When I say predefined provisioners, So this is with correspond to our environment, so which are commonly used across the images which we use, for our customers. And if we have to customize the image, we can use any bash scripts and use it over the fly in our framework. And you can choose any registered endpoints. Endpoints are nothing but OpenStack environments of any location. You can choose any location to push that image to. And once the image building process complete, scanning will be initiated. Based on the scanning report, like if the CVs are detected, then a framework won't allow that to be published. And in this demo, image will be clean and it will be pushed to the local centralized registry. Like this centralized registry is maintained, for usability, where we can use the same image in different endpoint. And publishing phase will onboard this image to the corresponding OpenStack registered endpoint. Okay, let me show that demo first. Yeah. So here's the landing page. Here, the lifecycle process is shown in 3 different phases: building, scanning, and publishing. As we can see, there are few images available already, which are prevented from being published to the endpoints. UID 128 scanning is failed, and then it's being blocked from being published. And let's look at the endpoint, where we'll make sure that there are no pre-baked images available, like just for demonstration purpose, so that I can launch an instance earlier and then demonstrate it. Yeah, here there are no pre-baked images, and let's look at the instances, and to make sure that there are no VMs running out here. And let's build a customized image that is for virtual machine. In this creation page, we can build an image for any platform. It might be virtual machine or container or a bare metal. And here we choose a hypervisor. We're building for KVM and predefined provisioners, which I mentioned earlier, that this is corresponding to our environment, which we commonly use. So we made it as predefined to make it more handy. And partition we can build for LVM and non-LVM. And LVM, just we'll try to customize it by resizing from 2 to 4, and these partitions are randomly selected. And let's create a custom partition as OpenStack rocks, and for 1 GB. And this is a mount point. And additional configuration, let me touch a file in temporary director to just demonstrate the capability. And this is a registered endpoint where I want to publish the image to an OpenStack environment. So image is in building process. So let me show the Packer functionality, how we are going to customize this entire process. So Packer uses kickstart file to automate the OS installation process, which is usually done manually. And here we have a partition segment. So this is where we customize the image customization, a partition customization. Right now we have a root 2 GB. And we don't have any customized partition. This is a base kickstart file. And let's see the customized kickstart file post trigger. Here we can see the customized kickstart file, OpenStack rocks, and we have a VG root for 4 GB. And Packer uses, this is VG root. And Packer uses JSON template as a primary template for provisioning and hardening stuff. So here we have a predefined provisioners which we have defined, and we can define any provisioners, if that is common to our platform later on. And here we can see the custom script. This script is a touch command which we have defined at the additional config. So this is how we can enhance the capabilities of customized provisioning. So Packer triggers KMO to initiate the building process and creation of hard drive, and it initiates OS installation process here. Yeah. So once it initiates OS installation process, kickstart file starts executing to create partitions and stuff, and Packer will take the control of the process. Once VM is up, then it will start executing all the provision scripts. Yeah, Packer started provisioning here, and the entire process is tracked over the UI. You can monitor the status and see the process on the go, and without having to look at the logs. I'm just demonstrating here logs to explain the process. And Once it is built, a scanning process will be initiated, and we execute OpenSCAP API to start the scanning process. And right now, it won't detect any CVEs because we want to show the publishing capability and make sure this image has customizable. Yeah, let's see the scanning report. Scanning is done. And here we have 88 CVE definitions, which are free from vulnerable, and test cases of those definitions. And as I mentioned earlier, it's publicly available. So those are reported by the various organizations. For example, for every Red Hat product, Red Hat releases OVAL definitions, that is security policy documents for its product. We can directly use them and scan the image, like to make sure everything is safe. And all the test cases are fine here. Yeah, let's see the image if it's published. Yeah, image is published, and let's look at the glance registry in our endpoint. Yeah, let's cross-check this image with the UID of the image which we have just built. Yeah, and let's go and launch this instance and verify whether the partitions are created or not. I won't trigger any volume. Yeah. So instance is spinning now, and so what we're going to verify here is the customized partition OpenStack rocks for 1 GB, which we have defined in the creation page, and also the file which we created in temporary directory. So these two things we're going to verify here. Yeah, here we can see the partitioned, customized partition as OpenStack rocks as a logical volume. And let's check the file. Yes, we have the file here, data.txt, which we created. And this completes the one use case. And the second use case is we use the same base image, CentOS 7, and provisioners, and we inject CV definition, like manufactured one, just to demonstrate that we can like detect the vulnerability to show the capability of the framework. Here, okay, sorry. So remove. Yeah, let's create the customized image. We'll use the same image and same hypervisor and provisioners. There's no change. But we'll just change the customized script. Yeah, and the reason for this yum installed Ruby, we just randomly picked a package and nothing against Ruby. It's and we have injected CVE for this just to detect vulnerability, as earlier mentioned. Image is building, and let's check whether the custom script is triggering or not. The script will be triggered in the UID name. Yeah, here we can see the custom script triggered for this particular image. And let's see whether if Ruby is installing. Yeah, here we are installing Ruby. Yeah, Ruby is installed. And let's scan the image and verify the report whether it detects that vulnerability or not. Yeah, let's check the report. So once the framework detects a vulnerability, its main motive is to keep the registry safe, the glance registry safe. So here the framework won't allow the image to be published. And here we can see out of 87 definitions, we have one unsatisfied definition. test cases. And here we have a Ruby security update. Yeah, this is a definition which we tweak to get detected. That's it. So let's move to the next demo. And this use case is to show primarily the capability that we can build, the framework can build the Docker images. And here we are not using any Docker files. We use Ansible playbooks to provision the containers. Here we have a platform, Kubernetes, and application. We can choose any application and platform and the base image, like on top of which we want to spin container. And the rest of the phases are same. So let's build a Docker image container. We'll choose Ubuntu base image, and we'll choose Nginx application, or just a random pick. And here we can provide any additional configuration, like environment variables and any configuration related stuff to Nginx and so on. And the publishing endpoint remains the same. So we are initiating the building process. And let's check the Docker registry. And before that, let's verify whether it's installing Ansible or not. Yeah, Packer is installing Ansible. Once the installation is done, it will install Nginx by using Nginx playbooks. And here we'll make sure the registry has no images. Yeah, I think we have one image. Let's delete that image. Yeah, here we can see Packer is provisioning the Ansible playbook. It's uploading the playbook and it's executing the tasks. Yeah, post completion of like creation of container, it exports the container image, which which is used by the OpenSCAP to scan the image and make it for further proceedings. Once scanning is done, like report is success, so it will be published to the registry which we just checked earlier. And here, this is a scanning report of a Docker container, and we have CV definitions corresponding to the Ubuntu image. So everything is safe. So let's check the registry. Yeah, here we have a Docker image which we just created. We'll just cross check with the UID name. Yeah, so these are the capabilities which we have built with our framework. And yeah, these are the references in case if you need any. And thank you. Any questions? Any questions, gentlemen?
Yeah, thank you. The web app, is that something you custom wrote? I see at the bottom oval. I'd like more details on the web app. Is that all just custom? Is that Java? Is that Node.js?
Web app is developed using Django, Python Django. Yeah, so we have 3 different models. I mentioned earlier that we have 3 different phases, right? Building, scanning, and publishing. So these 3 are independent modules developed using REST APIs. So this is a central framework, sits at a central server, and triggers all these like APIs as and when required.
Locally then, so Packer is local to where the web app is running? And it's just calling
no, we have, right now for the demo, yes, we have it, but the plan is to segregate them so that it's scalable across.
If you don't mind, could you give a little bit more details on where you're going with the the CI/CD from the pipeline perspective? In other words, I mean, I've kind of been thinking similar lines about some of the things I'm seeing here with Zool, triggers from GitHub, automating the merging. Just I need to prevent people from merging code that's going to break my builds. And so I wondered if you've thought through that, or you just know you want to think through that in the future.
Right, so the inspiration has come from the containers world, right? So you have a lot of CI/CD process already inbuilt into it, whether you have Jenkins and GitHub kind of thing. Similar thing, what we want to do is we want to have pipelines, probably in Jenkins or some of the CI/CD tools, which would go and trigger these changes, start building and then do it. Because our framework, we would want to expose APIs and write pipelines, and then go ahead and manage all your infrastructure that way.
Thank you.
Hi, my name is Omar. First of all, very impressive implementation and presentation. Thank you.
Thank you. Thank you so much.
Yeah, and I just have some multiple questions. First is, which release for the OpenStack you have picked and why?
We have picked Pike.
Pike?
Yeah, and the reason is there's no significance, by using Pike. That was your test environment, so we picked it. There's no.
But essentially, just to add on to it, but essentially it doesn't make a difference to us. What we are talking about is it's an API-based ecosystem, right? Mm-hmm. So you get any OpenStack, we may have multiple data centers running on maybe Mitaka, maybe Kilo, maybe anything, right? Okay. You could even have AWS. All we need is an API signature that you can go and make a call. Okay.
And which platform did you use for the for your OpenStack implementation? Is it Ubuntu? Is it CentOS? Is it specific Linux?
So from a service standard point of view that we are running on RHEL OpenStack right now.
Okay, it is a RHEL OpenStack,
right.
And it is Red Hat supported as well.
Yes, yes.
Okay, so that definitely. And then, what are your challenges? Did you ever gone through the upgrade? Because one of the biggest challenges in industries right now, upgrading an OpenStack. So I know Pike has been for some time now. Right. There's a lot of new things are coming up, and I saw that you're looking into Docker, and Docker has a Magnum plugin also came up. Right. And Pike. I don't know, are you using Magnum plugin or it is?
No, so what he's mentioned, Pike, is for your demo purpose that what we are trying to do. We didn't want to touch our production environment right now, right? Being very frank about it. But the OpenStack environment that we are running is RHOSP. I think it's on Newton that we have. And yes, upgrades has always been a challenge because it's all supported by Red Hat, so we'll have to probably work out in case we want to move forward.
Okay, I think so that'll be all. Thank you.
Thank you.
Thank you.
Hello. Thank you for the presentation.
Thank you.
I have one question about Nova image cache. Okay. So I want to know, because from what I understand, each time you create a new customized image, it's a new image in Glance. Right. So it means that each time a customer wants to use the image, it will be cached in the first hypervisor where it's scheduled. So how do you ensure that you're not growing too fast the local disk on your compute, and still ensuring a good provisioning time for VMs?
Right, so caching will always be a challenge because what we say is when somebody wants to customize it again and again, I mean, when a customer onboards, you would want to customize that image, and that'll be the first signature that you'll be having, so it will not be cached. So our caching policies have to be set accordingly, and then we do have even a daemon to ensure that keep on check of how much you are being caching and recycle it as the need be.
Okay, thank you.
Thank you.
Hi, I'm Tom. So in your scanning, you said you are scanning for the vulnerabilities, right? So in addition to vulnerabilities, are you scanning for the performance degradation or anything like that?
No, not right now. It's typically the compliance and vulnerabilities that we want to really look at it from this point. When we are talking about CI/CD and all, we may want to look at it that moment that there was a performance. I mean, it's a complete infrastructure that you would want to design it, because performance would not be as such from an. So if you're talking about performance from an application point of view.
No, I'm talking if meltdown spectra. So.
Oh, okay.
So
gotcha.
that kind of.
So I think for that also we'll have CVEs defined, and the test probably would be there, and that's what we would want to. Anybody sees the CVE, they publish it. It has to be in our OVL file, and then once you scan it, you'll be able to figure that out.
Right.
That sort of thing.
Thank you.
Right. Thank you.
Hi.
Hi.
Quick question.
Sure.
You said you're scanning your images before you deploy them to endpoints.
Right.
Do you scan once, or is that an ongoing thing?
Right, so yeah, that's interesting, right? So first is whether you're able to bring an image, because once you create a VM, customer has a control over on top of it, and he can go and install anything else, right? So that's the second step that we want to consider. How do you manage security on a runtime of an image? That's something that we are still exploring it. How to do it, yeah.
So for your question, do we scan only one time? So in the presentation, we have mentioned that once we scan the image, we push to centralized local registry. So that is a centralized local registry available across all the endpoints. So once the image resides there, that literally means that is safe image, because once if we detect any vulnerability, we are not pushing that to any registry, right? So that image will be reused across the endpoints. And if you onboard that to a particular endpoint, say endpoint A, so no need to build another image or no need to like pull the image from there. It's already there in endpoint. Only for the different endpoint, we're gonna pull that image.
So my concern was if your image factory got compromised, you know, and then you're using a compromised image basically.
Okay, that's something we need to look for. Thanks. Thank you. Thank you everyone for attending the session. Thank you so much.